Here we are going to discuss the solution of quadratic equation within 1 second. It is sure that all the quadratic equation cannot be solved within 1 second, but there are certain quadratic equations that can be solved within the few second. I mean, when we see the question, we can say whether the parameter x greater than or equal to y or so. Here I am discussing such two types of quadratic equation that can be solved within 1 second, but I mean just within the time we see them. First we go to such two examples. First category, that is 20x square plus 34x minus 987 is equal to 0, and 76y square plus 9y minus 346 is equal to 0. In these cases, the coefficients of x square x and constant number, as well as coefficients of y square y and the constant number will be bigger one, because we feel it difficult to solve. Why? It is because of the fact that we are unfamiliar with that first trick. And the second category, it will be like the 29x square minus 3x plus 990 equal to 0, 72y square plus 95y plus 746 equal to 0. In this second category also, whether the number which is higher or a prime number, then we will be difficult to arrange the roots for the values of x and y. Here also we will have the same challenge, but there is one common trick for these two categories that is going to be discussed here. That is, we can solve these two categories of quadratic equation within the time we just look at the question. Without much introduction, I am going to the examples of these two questions along with the trick. First category, let the quadratic equation of x and y be a1x square plus b1x plus c1 is equal to 0 and a2y square plus b2y plus c2 is equal to 0. If the values of c1 and c2 are negative, then we cannot compare the values of x and y. Why it is so? If the values of c1 and c2 are negative, then it indicates that one of the value of x is positive and the other value of x is negative. Similarly, if the value of c2 is negative, then one of the values of y will be positive and the other will be negative. If one of the value of x is negative and other is positive, and y the similar order, then we cannot able to compare the value of x and y. I am giving with the numerical examples like 5x square plus 6x minus 8 is equal to 0, and 5y square plus 3y minus 8 is equal to 0. In the two cases, value of c1 and value of c2 are minus 8 and minus 8 respectively. Hence we can apply the first principle. We need not to take care of the constants a1 and b1 as well as a2 and b2. We just take care of the value of constant c1 and c2. Both these two are negative, then we can directly get into the option that we cannot compare x and y. And I have given further examples here, that is 11x square plus 4x minus 13 is equal to 0, 16y square plus 5y minus 34 is equal to 0, and a third example has also been given. And we just come back to the previous question, that first category 20x square plus 34x minus 987 is equal to 0, and 76y square plus 9y minus 346 is equal to 0. Since both the values of c1 and c2 are negative, hence we cannot compare x and y. Hence the first category we have finished with ease, and then we are going to the second category. Here the second category, the equation, let it be a1x square plus b1x plus c1 is equal to 0 and a2y square plus b2y plus c2 is equal to 0. Both c1 and c2 are positive and either b1 or b2 is negative. b1 is negative, bx greater than y and vice versa. We will explain with the one example. Let 5x square plus 6x plus 8 is equal to 0 and 5y square minus 3y plus 8 is equal to 0. Here we have both the values of c1 and c2 are positive. That is, we cannot able to apply the first principle, that first constant as well as second constant both are plus 8, and the second condition for applying this principle is value of b1 and b2, one of them must be negative and the other must be positive. Check whether the second condition has been satisfied or not. In the first equation, 5x square plus 6x plus 8 is equal to 0, value of b1 is positive, whereas in the second equation 5y square minus 3y plus 8 is equal to 0, b2 is negative. Hence we can apply the second principle, that is b2 is negative and b1 is positive. Since b2 is negative, the parameter for this equation, second equation, y will be greater than x. I mean, whichever the coefficient is negative, the corresponding variable will be higher in magnitude. We are getting into second example. In this case also, first check whether c1 and c2 both are positive. Yes, it is satisfied. In the first equation it is plus 13 and the other equation it is plus 34. Then check into the second condition, b1 and b2, one of them must be positive and other must be negative. In the second example also, the b1 is negative and b2 is positive. Hence both the two conditions are satisfied. Hence we can directly get into the opinion, that conclusion, that the example b1 is negative, the coefficient of x is negative, hence x will be greater than y. Similar, in the third case, c1 and c2 are positive and b1 and b2, only one among them is negative. Hence we can conclude that x greater than y. And we are getting into more examples for this. Let first example, 9x square plus x minus 8 is equal to 0, 7y square plus 34y minus 1 is equal to 0, and from the values of c1 and c2 both are negative, hence we cannot compare x and y. And from the second example, we can get value of c1 and c2, both are positive, hence we cannot apply the first principle. But while checking the value of b1 and b2, only b1 is negative, b2 is positive, hence we can apply the second principle. Since the value of b1 is negative, the corresponding parameter, corresponding variable will be higher, that is x greater than y. In case of third example, both values of c1 and c2 are negative. Here 16x square plus 34x minus 1 is equal to 0 and 11y square plus 9y minus 9 is equal to 0. Both c1 and c2 are negative, hence we can conclude that x and y cannot be compared. Similarly, this is the case of fourth example. Both c1 and c2 are negative, hence in the case of fourth example also we cannot able to compare x and y. And in case of the fifth example, we have seen that value of c is negative in case of first and first, and in the case of second example it is positive. Hence we cannot apply the second principle also. We must not forget that there are two principles to be followed in the second case. See the conditions: both C1 and C2 must be positive, and only one of the parameter B1 or B2 must be negative. If both are negative, we cannot apply the second principle, and C1 and C2 must also be positive. But in this example, fifth example, C1 is negative, hence we cannot apply the second principle also. Hence this parameter cannot be applied. This equation cannot be solved using first and second principle. And the sixth example, you can see the value of C is negative in both the examples, hence x and y cannot be compared. In the seventh example also, value of C is negative in both the cases, hence x and y cannot be x and y cannot be compared in seventh question. And in the case of eighth question, we can see value of C is positive and only B1 is negative, B2 is positive. Hence the two conditions of the second principle is satisfied. Hence the value of B1 is negative, x will be greater than y. And the ninth example, both C1 and C2 are negative, hence those x and y cannot be compared. And the 10th example also similar is the case, C1 and C2 are negative, hence we cannot able to compare x and y. And in the case of 11th example, it has been shown that the value of C, only one among the values of C is negative, hence we cannot use these two principles to answer the 11th question. But in case of 12th and final one, it is given that value of C is negative in both cases, hence we cannot compare x and y in the 12th question. Thank you. We will discuss the further 3 tips for quadratic equation in the coming classes. Thank you.